So in this lesson, we're going to look at absolute value graphs and transformations of those graphs. We'll talk about what that means. And so our goal for today is if we are given an equation that looks like what I have here in blue, we will be able to identify what each of those things do. So what does the negative, the a, the minus h, and the plus k do? And we'll talk about that, and we'll summarize that at the end of this lesson. So let's start out by just graphing the regular absolute value graph, y equals absolute value of x. And so if we look at the table here, if we have y equals absolute value of x, then the absolute value of negative 3 is positive 3. The absolute value of negative 2 is positive 2. Absolute value of negative 1 is positive 1. Absolute value of 0 is 0. Absolute value of positive 1 is positive 1. Absolute value of positive 2 is positive 2. The absolute value of 3 is 3. So remember, absolute value is just how far away something is from 0. So if we graph this on our graph, we've got, let's get ourselves enough room, there we go. We've got negative 3, 3, negative 2, 2, negative 1, 1, 0, 0, 1, 1, 2, 2, 3, 3. And these lines will keep going on forever because you'll end up with 4, 4, 5, 5, 6, 6, 7, 7, and so on. So this is just the normal absolute value graph. One very important thing I want to point out is this is called the vertex, and that vertex is really important for the rest of these graphs. We need to make sure that we find that vertex on every absolute value graph. So every time you have an absolute value graph, it's going to look like a V, and it's going to have a vertex. Now that's the tip of that V. All right, so what shape is the absolute value graph? It is a V. Next, let's do this one. So this is pretty much the same thing, except we're taking that x value and we're going to add 3 before we do the absolute value. So let's do that. This one is going to be negative 6 plus 3, which is negative 3. And then we do the absolute value of that, which is 3. And then right below that, we would do negative 5 plus 3, which is negative 2. Absolute value of that is 2. Negative 4 plus 3 is negative 1. Absolute value is 1. Negative 3 plus 3 is 0. Absolute value of that is 0. Negative 2 plus 3 is 1. Negative 1 plus 3 is 2. And 0 plus 3 is 3. If you notice, the numbers I picked for x this time, I shifted those down 3 so that I could get that vertex. That's the whole point. So if you don't see your numbers going down and then going up again, then you want to make sure that you adjust your x's so that you see that V in the graph. So let's graph this. Negative 6, 3, negative 5, 2, negative 4, 1, negative 3, 0, negative 2, 1, negative 1, 2, 0, 3, and boom. So what happened to this graph? If we had an x plus 3 inside the absolute value, that shifted the graph what way? It shifted it to the left 3. And we call that a translation. So transformations are, how is this graph moving? One way to transform a graph is by shifting it left, right, up, or down, and so this is a translation left 3. All right, let's look at the next one. So if this one is y equals absolute value of x minus 5, you should try to take a little mental estimation on what's going to happen to this, and you probably can guess just based on what happened with the last one. So if I plug 2 in here, 2 minus 5 is negative 3. The absolute value of that is 3. If I plug 3 in, then 3 minus 5 is negative 2. Absolute value of that is 2. Plug 4 in, I get negative 1. Absolute value is 1. Plug 5 in, get 0. 6 minus 5 is 1. 7 minus 5 is 2. 8 minus 5 is 3. So I'm going to graph these points. We've got 2, 3, 3, 2, 4, 1, 5, 0, 6, 1, 7, 2, 8, 3. So our graph's going to look something like this. And so what happened? Well, if we have an x minus 5, that shifted it to the right 5. And that is also a translation. Okay, what if we have the plus 4 on the outside? So let's see what happens here. If we plug negative 3 in for x, the absolute value of negative 3 is 3, and then the plus 4 is after the absolute value, so now the y is going to be 7. If we put negative 2 in, negative 2 plus 4, absolute value of negative 2 is 2. 2 plus 4 is 6. Put negative 1 in, absolute value of negative 1 is 1. 1 plus 4 is 5. 0, absolute value is 0, plus 4 is 4. And then the absolute value of 1 is 1, plus 4 is 5. 2 plus 4 is 6. 3 plus 4 is 7. So let's graph this. We've got negative 3, 7. 1, 2, 3, 4, 5, 6, 7 right there. Negative 2, 6. Negative 1, 5. 0, 4. 1, 5, 2, 6, 3, 7. And there we go. So what did the plus 4 do? Well, that thing right there moved it up 4. That's also a translation. All right, so you probably guess what the minus 7 is going to do. That is going to, we're just going to behave the same way as what we did before. So the absolute value of negative 3 is 3. 3 minus 7 is negative 4. Absolute value of negative 2 is 2. 2 minus 7 is negative 5. 1 minus 7 is negative 6. 0 minus 7 is negative 7, and so on. So if I graph this, and I know I went kind of quick, but hopefully at this point we're kind of getting it. Negative 3, negative 4 is right there. Negative 2, negative 5 is right there. Negative 1, negative 6. 0, negative 7. 1, negative 6. 2, negative 5. 3, negative 4. So our graph's going to look something like so. And so what did that minus 7 do? Well, that went down 7. And that is a translation as well. It's a translation down 7. So let's look at a couple more examples and see what's going to happen. Some will not be translations. So what's going to happen if we have y equals negative absolute value of x? Well, a lot of people think, well, absolute value is always positive, so it's always going to be positive. But what's happening here is we take the absolute value of negative 3. So maybe, let me write this out. So we do the absolute value of negative 3, and then we make it negative. So that's going to be negative 3, because the absolute value of negative 3 is 3, and then we make it negative. So same thing with negative 2. Absolute value is positive 2, but then make it negative. Negative 1, 0, negative 1, because the absolute value of 1 is positive 1 is 1, and then make it negative. Absolute value of 2 is 2, then make it negative, and so on. So it's going to look like that. So what's this going to look like on our graph? If we have negative 3, negative 3, negative 2, negative 2, negative 1, negative 1, 0, 0, 1, negative 1, 2, negative 2, and 3, negative 3. So what happened to this graph? And hopefully you're telling yourself it just flipped it upside down. And that's exactly what happened. And so the math way of saying this is it is a reflection over the x-axis. So this is considered a reflection. That is the type of transformation we're talking about. You could say it's flipped upside down, and that is correct, but the mathematical term we say is reflection over the x-axis. All right, what if we plop a 3 out in front? Instead of a negative, what if we put a number out there? Then what's going to happen? Well, it's going to be pretty similar to what we saw earlier. So this is going to be 3 times the absolute value of negative 3, which is 3 times 3, which is 9. So then what if we put negative 2 in? We would have 3 times the absolute value of negative 2, which is 3 times 2, which is 6. And then same thing with negative 1, be 3 times 1, which is 3. And then I can fill in the rest. This would be 0, 3, 6, and 9. If you want to plug them in to prove that I'm right, go right ahead. So let's graph these. Negative 3, 9. This is 7, 8, 9. It's like up here. Negative 2, 6. Negative 1, 3. 0, 0. 1, 3. 2, 6. And 3, 9. So it's going to be a much more steep V than what we're used to. Just to kind of give you an idea, I'll do this in yellow. The yellow graph is going to be our normal absolute value. This is called a parent function. And so the parent function is in yellow. The blue one got a lot skinnier. So how does this graph differ from the original graph? Well, it's skinnier, which, as you can probably imagine, is not a technical term in mathematics. But what we say is this is a vertical stretch by a factor of 3. You could say a factor here. So if you go into higher math like a pre-calculus or calculus, they will call this a vertical stretch by a factor of 3. Skinnier is a great way to describe it. This is the mathematical way to say it. Okay, what if we did a 1/2 out in front? How is that going to change it? So let's do the same thing. Let's plug stuff in. If I have negative 6, we're going to do 1/2 times the absolute value of negative 6. Notice I changed these x's here, right? 1/2 times the absolute value of negative 6 would be 1/2 times 3, which is, or excuse me, I jumped the gun there, didn't I? Be 1/2 times 6, which is 3. And then if we do 1/2 times the absolute value of negative 4, we get 1/2 times 4, which is 2. Plug in negative 2, absolute value of that is 2, half of that is 1, and so on. So let's graph this one. What's this going to look like? Negative 6, 3 is right there. Negative 4, 2 is right there. Negative 2, 1 is right there. Got a little extra. There we go. 0, 0, 2, 1, 4, 2, 6, 3. It's going to look something like that. And just for reference sakes, the original graph, the parent function, just absolute value of x, looks something like this. So what happened? Well, it stretched this wider. So it got more wide or wider. And so what we call that is a vertical compression is what happens. A vertical compression by a factor of 1/2. So what this means is it's really taking this yellow graph and it's squishing it down vertically by a factor of 1/2. It's compressing it down. Almost think of it like, if you take a picture on a computer and you just drag the top down and it kind of squishes that person's face or something like that. Okay, and then our last one. What if we had a -2 out in front? Hopefully you can kind of guess what's going to happen here. What does the negative do, and what does the 2 do? And hopefully you can kind of picture what that graph's going to look like in your head right now. So let's plug stuff in and see what happens. We've got -2 times the absolute value of -3, which is -2 times 3, which is -6. And then we would do -2 times the absolute value of -2, which is -2 times 2, which is -4. And plug -1 in, we get -2, 0, -2, -4, -6. Okay, so -3, -6 is down here, -2, -4 is down here, -1, -2, 0, 0, 1, -2, 2, -4, and 3, -6. So, what did it do? Well, it flipped it upside down, and it also stretched it out. So if we just flipped it upside down, the graph would look like this. This yellow one is the negative absolute value of x. So it also stretched it out even further. So what happened here? This is a reflection over the x-axis, and it's also a vertical stretch by a factor of 2. So this is a marathon note session. Apologize it's taking so long, but let's summarize everything we've learned so far. It's a lot to take in. So the parent function is over here in red. That is just absolute value of x. And then let's talk about what happened with all of these transformations. So let's start with a. That number out in front, if we have f of x equals a times x minus h plus k, if that number out in front is bigger than 1, then it is a vertical stretch by a, we'll say. If it's between 0 and 1, so like we saw 1/2, then it would be a vertical compression. Sometimes you'll hear it called a shrink, so that could also be used by a. And then if a is negative, it's a reflection over the x-axis. Okay, let's talk about h. And what I'd encourage you to do, which you should always do with notes, is think about what the answer is going to be before I tell you. So for h, if it's x plus h, then what did we see earlier on in the notes? Then that means the graph moves left h. It's kind of the opposite of what you'd think. If it's plus, we usually think it moves to the right, but that actually is going to counter it to the left. And if it's x minus some h value, then it's going to move it to the right h. And this is always assuming that, you know, h is a positive number. So we wouldn't do like x minus -3. That would be considered x plus 3. Okay, and then the last thing, if k is positive, the last number, that moves it up k. And if it's negative, moves it down k. So those are all the different transformations that happen with this absolute value graph.